Alright guys, welcome to your physics test review. It's your last test review for me, and it's your last test in physics. What? That is unbelievable. So you guys have done a great job. I'm going to post like a class party video in the next couple of days, so be on the lookout. It's going to be great. Okay, so just to let you guys know, your test is going to be a lot content-based. You will have momentum problems on there. So momentum equals mass times velocity. So I'm not going to go over that for this review. And just be sure you understand the definition of momentum and of impulse. And make sure you know impulse momentum theorem, the definition for that. You also need to be sure that you know the unit of measurements for both momentum and impulse. So be sure that you go back into your videos and look at that. I'm doing this test review video with the assumption that you've watched all the lecture videos and all the YouTube videos that I've told you to watch. So what I don't want to happen, and I say this in all three of my classes, is I don't want you to just watch the test review video and think, oh, I'm ready for the test because I've watched this. So you need to make sure that you're going back and you're taking good notes because all of it is fair game. So just because I don't talk about it during this test review doesn't mean it won't be on your test. In fact, there's not a whole lot of content as far as like definitions and stuff for this test. So if I were you, the impulse momentum theorem problem that I gave you, that whole video, I would be very sure that I know how to do that. And I'm about to do another one here with just different numbers because you will have three problems like these, but they're going to be very heavily weighted on your test. So you got to make sure that you know these, okay? Yes. And as always, I will give partial credit if you turn in your work and all that good stuff. So I will give points where points are due, but please be sure you know how to do these before, Friday morning because your test is at 11. So, all right, let's go ahead and do this problem. So this is exactly how it would look, except it's not going to be in a picture form. It would be in a word problem form, which we talked about in the last video. So I'm asking you for 4 different parts of this problem. So with a problem like these, like this one, these 4 different parts would count as 4 different pieces of the partial credit, okay? So we're looking for impulse, which is I. We're looking for our change of P, or our change of momentum, P final, or momentum final, and velocity final. So let's go ahead and get started with this. So a few things that we know. We know that impulse is equal to force times change over time, which is equal to change in momentum. And what is change of momentum? Change of momentum is written in triangle P. But when we expand that formula, it's going to be our mass times our change in velocity. So in this problem, we have an object that has a mass of 75 kilograms being pushed with a force of 300 newtons at an initial velocity of 12 meters per second in 10 seconds. Now, make note, this is our change in time. This isn't our initial time or our final time. This is our change in time. I went ahead and gave you that piece of the puzzle. So let's go ahead. The first thing that we would want to find is our impulse. So what would our impulse be? Well, we already know that. Impulse is equal to force times our change in velocity, or change in time, rather. So our force is 300 newtons times our time, which is 10. And remember, this is why impulse is written in newtons times second, because force has a unit measurement of newton, and time has a unit measurement of seconds. So this is going to be 3,000. So we already know our impulse is 3,000 newtons times seconds. Okay, that's awesome. Another thing to note is, what other piece of this puzzle do we already know for sure since impulse is equal to 3,000? Our change in momentum, because impulse is equal to our change in momentum, right? So our change in momentum is going to equal what? 3,000. Now we can double check this by doing this problem right here, this side of the problem, because remember, this is my impulse, and this is my change of momentum, okay? So, and we're going to have to figure this out anyways because we have to, in order to find our final momentum, we have to find our final velocity, okay? So we have to do this portion of the problem anyways. But so this is equal to 3,000 And then we're going to write, what's our mass? So our mass is going to be equal to 75 kilograms, right? Times our change in velocity. What, if we were to write out the formula for change in velocity, what would it be? It would be our final velocity minus our initial velocity. Do we have our final velocity? No, we don't have our final velocity, so we're going to write VF. Do we have our initial velocity? Yes, we have it written right here. It's going 12 meters per second, so it's going to be minus 12. So then we have 3,000 is equal to 75 times our final velocity minus, what's 75 times 12? $900. So in order to get our final velocity by itself, to figure out its value, we have to move 900 over to the other side by adding it to both sides. So now we have 3,900 is equal to 75 VF. What do we have to do to 75 with the 75 in order to get it onto the other side? We have to divide it, right? So go ahead and put in your calculator. I'm going to double check mine. We're going to put 3,900 divided by 75 equals 52. So our final velocity is equal to 52 meters per second. Okay? All right, so let's go ahead and plug that in here. What's great about finding our final velocity, not only can we figure out our final momentum now, but also we can double check our work and make sure that our change in momentum is correct. So I'm going to erase this. So the way we do that is, remember, this is our change in momentum, so we want to make sure that it equals 3,000, right? So our mass is, I'm just going to do this portion of the problem. So our mass is 75, and it's going to be times our change of velocity, which, what is our change in velocity? It's not 52 and it's not 12, right? It's going to be 52 minus 12 because that's the change. Okay, so 75 times 40 is equal to 3,000. Perfect. All right, so we know that our change of momentum is correct, and we know that our impulse is correct because impulse is equal to change of momentum. All right, now the last portion of the problem. Now we want to figure out what our final momentum is. And our final momentum is our momentum equation, which is P equals mass times velocity. And when we're finding our final momentum, it's going to be our final velocity that we multiply it by. So just be careful of that. Don't think that in order to find our final velocity or final momentum, don't do the same equation as change in momentum, okay? All right, so PF is going to equal to mass, so 75, times what is our final velocity? Remember, it's our final velocity we're finding, 52. So 75 times 52 is equal to 3,900. 3,900. All right? Okay, guys, hopefully that all makes sense. I really enjoy doing these problems. They're super, super fun. At least I think they are. The problems on your test will look just like this. I'm not going to throw you a curveball. I'll be sure to give you the change of time value. I'm not going to ask you to find the change of time. Everything that you just saw here is what will be on the test. Please be sure you know how to do these because this is going to weigh a lot on your test. So be sure that you are practicing and getting these as best as possible. And if you need any help whatsoever, you know the drill. There it is. Inside Out. I put it on for her because, you know, she does Frozen too. Like, she loves Olaf and all of that good stuff. And so we've been watching that, like, every single night. And anytime I need to, like, record a video or whatever and I just have to, like, be completely focused, I'll let her watch a little bit. So I tried Inside Out because I wanted her to do something a little bit different because I've been watching a lot of Frozen too. But she fell asleep during Inside Out. And I was pleasantly surprised. I'm, like, halfway through this because she fell asleep within the first 20 minutes and now she's down for a nap. And I was like, this movie is way better than I remember. So, but this is not physics related, but the best Pixar ever is onward. It's true. And you can't disagree with me about it because I'm the teacher, so. No, I'm just kidding.